Okay, so perfectly inelastic collision. Perfectly inelastic collision. Of course, head on we are talking. Okay, or 1D, one dimension collision. So perfectly inelastic collision, remember the moment is coming in your mind. We have to remember that objects will stick together. Best example is, like suppose there is a wooden box or some plank, wooden plank is there on the surface, right? Wooden plank is there on the surface and there is a bullet. Okay, M1, this is U1, this is M2, this is U2. Okay, so what will happen? The bullet will get embedded inside. So after the collision, they will move together. That is a characteristic of perfectly inelastic collision. So the bullet will go inside it. Okay, and they will move with V common. So we are not saying V1, V2. Remember, common velocity. Why common velocity? Because they are moving together. So whenever this type of question is coming, when objects are sticking together, right, we'll say it is perfectly inelastic collision. Okay. So in perfectly inelastic collision, objects will stick together after collision. Similarly, there can be some problem, something like this also in some books. If you'll see, they will give something. Okay, something is hanging, right? And one bullet is going, it is hitting it, and after that they will ask that combination will go how much height, like this type problem. So here at this moment when it is going inside, that is again perfectly inelastic collision. So whenever this type of problem is there, or suppose they are telling there is two tennis balls, right? They are approaching each other. They are approaching each other, and after certain time, they are sticking together, right? There some Fevicol is used or something is used. What chemical is used, not importance in physics. Only thing is we have to see that they are moving together or not. If they are moving together, it is a case of perfectly inelastic collision. Okay, perfectly inelastic collision. So in this case, remember one thing, momentum conservation is the single equation available. Energy is lost. In perfectly inelastic collision, momentum conservation is valid, but energy is lost. Okay, but momentum is conserved. Of course, momentum total we are talking, because logic is still same. When A is applying force on B, even if it is inside, when they are applying force on each other, if M1 will apply force on M2, M2 will also apply equal force by Newton's third law. So momentum conservation is valid, total momentum conservation, but energy is lost. Hence, energy conservation is not valid. In fact, the good thing is there is only one velocity here, V common. So we don't need the second equation. In fact, it's very simple. It's very, very simple. We can conserve the momentum. Conservation of linear momentum we can apply for the system. M1 and M2 together. Initial momentum together. M1 U1 plus M2 U2 is equal to M1 plus M2, okay, into V common. Or from here the V common will be M1 U1 plus M2 U2 divided by M1 plus M2. So we don't need one more equation to get the velocity. Single equation, conservation of linear momentum, if we'll apply, we will get that. So this will be V common. Okay. This will be V common. M1 U1 plus M2 U2. Okay. Divided by M1 plus M. So any doubt, anyone in this? Now in this case, we can calculate even loss in kinetic energy. How much is the loss? Energy is lost. How much is lost? That we can calculate. Okay. So the second part of this will be calculation of loss in kinetic energy. So we can calculate loss in kinetic energy. Remember, whenever we calculate loss, we have to take initial minus final. Because if it is a loss, definitely final quantity is less. So we can write this as K initial total minus K final total. Total means both the object together we have to take it, not just single object. Total loss in kinetic energy has to be calculated in totality by M1 and M2 together. So Ki total minus Kf total. Okay, which we can write as Ki total. How much will be Ki total? Half initial M1 U1 square. This is for first object plus half, right? M2 U2 square. This is for the total. This will be initial kinetic energy. Okay, half M1 U1 square plus half M2 U2 square minus K final total. Now finally, if you'll see, they are moving together. So I'm writing mass as M1 plus M2 and V common, whatever common velocity we calculated, is square of it, of course. So this will be there, right? So this is loss in kinetic energy. Half M1 U1 square plus half M2 U2 square minus half M1 plus M2 V common whole square, which we can write as half M1 U1 square. Now we have to simplify it. So let me just put the value. Half M1 plus M2 V common. V common we already calculated. M1 U1 plus M2 U2 divided by M1 plus M2 whole square. Right? Which will be equal to, now one M1 and M2 denominator whole square is there. One is numerator, it will get cancelled. Half I'm just taking out common. So we can write like this: M1 U1 square plus M2 U2 square minus M1 U1 plus M2 U2 whole square divided by M1 plus M2. Remember, M1 plus M2 whole square was there, but numerator one M1 plus M2 is there. So that is cancelling one of M1 and M2 in the denominator. So remaining is one of M1 and M2, which will be equal to half. We can write M1 plus M2 in denominator, M1 U1 square plus M2 U2 square into M1 plus M2 minus M1 U1 plus M2 U2 whole square, which we can write as half M1 plus M2. We can multiply the term. So we individual M1 will multiply it here. So how much it will be? M1 square U1 square plus M1 M2 U2 square plus M1 M2 U1 square plus M2 square U2 square minus, now here it will be M1 U1 square plus M2 square U2 square, A square plus B square plus 2AB. Right? Just see. A plus B whole square, A square plus B square plus 2AB. Now in this, some term will get cancelled. Which are the term getting cancelled? You can see here m1 square, u1 square, m1 square, u1 square. Once we'll open the bracket, minus plus will get cancelled. Similarly, m2 square, u2 square will get cancelled. So in fact, you can see here each and every surviving term will have m1 into m. So we can write this as half m1, m2. We can take common. We'll get u2 square plus u1 square minus 2u1 u2 divided by m1 plus m2, which we can write as half m1 m2 divided by m1 plus m2 into u1 minus u2 whole square. Okay, so this is loss in kinetic energy formula in perfectly inelastic collision. In perfectly inelastic collision, right? In perfectly inelastic collision, this will be loss in kinetic energy formula. So any doubt, anyone? Any difficulty in this? This formula, of course, you have to remember, because in the exam they are asking perfectly elastic, perfectly inelastic. These are two extremes of head-on collision. In between also a lot of collisions are possible, but these two are well defined in all the books, including NCERT, everything, and favorite questions are coming for any exam based on these two, either perfectly elastic or perfectly inelastic collision. And this is loss in kinetic energy formula for perfectly inelastic collision. Okay, loss in kinetic energy for perfectly inelastic collision. Okay, so any doubt, anyone now? Remember the formula, half m1 m2 divided by m1 m2 into u1 minus u2 whole square. Okay, so this is perfectly inelastic collision. So we discussed perfectly elastic and then perfectly inelastic.